What up, you amazing hackers? It's your boy, the humble hacker from Chicago, Sha Ronin, back with another module for our pen testing series. And today, we are going over password cracking. Let's get cracking. First off, what is password crack-a-lacking? Password crack-a-lacking is the process of recovering data that has been stored or transmitted by a computer in scrambled form. Scrambled not meaning eggs or a skit by the amazing comedic trio, the Three Stooges. I prefer Curly, not anyone else after him. Fight me on it, you will lose. Now, these are the type of scrambling I'm talking about. As we see, we have a couple where we have phrases that are hit with hash functions and creates this output here. So all of this here is a computed via algorithm version of this data here. Now, what are we going to be going over? Obviously not over this in a boat, maybe over some walls, but for damn sure not this jet ski. We'll be going over these applications. We'll be going over Cool and Crunch, not Nestle's Crunch, because that's the Dust thing. This disgusting looking heifer right here who doesn't know what a comb is. Oh, sorry, that's Medusa, my bad. We also have our Hydra password cracker. We have a nice and cool, not a jive turkey Hashcat. And we have John, not Jack, the Ripper. Now, what is cool? Me, damn it. Just kidding. Let us keep it pushing. Cool is actually a wordless generator, and the abbreviation is for custom wordless generator, which begs a very interesting question. What the hell is this for? Because by my simple reading comprehension, there is no E in custom. So why is it there? How about you change it to an O, a different vowel that actually fits the, letters of the word custom? I don't know. Anyway, moving on. Now, what is cool? What cool does, similar to, not really similar to Crunch, because we're going to get into that next. What cool does is that it will spider a target page, and it'll go from depth either 1 through 5, and it'll find certain words that are unique. And it will also provide a count of said words that it had discovered. How does it work? Stop yelling at me and I'll tell you. Now, again, Cool and Crunch work similar but are separate. Cool will actually dig through the web page in order to find potential passwords or whatever patterns that we can look up. Crunch will actually generate generic passwords based on the minimum and maximum length of letters. Now, these are our spider crawlers. This is a disgusting and criminal roach. I hate roaches. I'm from Chicago, and me and roaches have very, 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 very bad blood. Now, let us keep it pushing. If you want actual, generated word lists, where do we go to find those? Easy. Daniel Messler's GitHub. This is an amazing selection of word lists from either password cracking or with usernames. This is updated a lot. And so every time that somebody comes up with new information to add to these word lists, the GitHub page is immediately updated. So always, always, always keep tabs on this GitHub repository in order to make sure that you're getting an updated word list to use. Now, back to life. Back to the CeWL. I am not singing anymore. Thank you, because I stink. I'm just as bad as roaches. Let's keep it moving. So how do these things work? Now, for the cool cat of cool, our syntax is going to be as follows. We simply call the application, specify the path that we want it to dig for, and the actual full path, and it will write the output to a file. We can also perform a count as well, including authenticating to a web page and crawling it that way. This is going to be a little bit easier, so let us take a peek at how to do that. Here is our sec lists here. As you see here, these things do get updated. So some of them not. But we see here, we have these word lists that are fairly old, but word lists such as password word lists, updated 18 days ago, miscellaneous ones, 18 days ago, same thing for fuzzing and discovery. So it's always, so again, it always pays to keep good eye on this repository just to have updated tools. Now, this is our BWAP application that we're going to be using to test the login form. There we go. Okay, what are we going to be doing? First off, we're going to create our word list here, and we're going to specify cool. And here's syntax for auto completed for getting our authorization, but we're just going to do this one first. 192.168. 128. And we're going to write it to a file. Now, there is no output. That is because it saved it to a file. So what we do is we call the application. We call the file. And as we see here, it printed out every word that it located on this main page, including the source code, and it found, not including the source code, sorry, but on the main page itself from here and all the links that are included on the main page, and it gave us this output here. So we can do the exact same thing, but instead of outputting as a word list, we can simply authenticate as a user and pull the same information that way. So we have our auth type underscore and there are no equals, not in terms of power, but the actual equal simple. Moving on, we specify this here. So now it will authenticate under basic with the username and password, and it should find either the similar amount or even more than that. So yeah, because we didn't save it to a file, so it's pretty much getting like the same data. So now that that is done, our crunch is going to work a little bit different. So for crunch, and this is why I don't like this application, because it's fairly useless. Meaning, again, as I already explained, what cool does is that it'll create a generic word list based on the minimum and maximum amount of letters that you assign it. The problem with that is that if there's a password that is complex, this is not going to cut it. And if we want to generate a password list that is at least 5 characters and above, it's going to create a major problem. And let us find that out. We're simply going to go ahead and call crunch. Give it a minimum of 5 letters with a maximum of 10. Output. Give it this file. And here's basically what it'll do. It'll compute how much space total that it would need to create a password list of a minimum of 5 characters to a maximum of 10 characters. And as we see, it is a lot. 1 petabyte just for that. Okay? This is almost 1.5 terabytes just for that. That is no, absolutely not. It's like trying to find a TV at the dollar store. Yeah, it ain't happening, Captain. So let us keep it pushing, shall we? Hashcat. I quote the great Alonzo from the world famous film Training Day. This is chess, it ain't checkers. So how do we use Hashcat? First off, Hashcat has an extensive list of commands and syntax that we have to use for it. So let's go ahead and pull that up now. But it is for a very important use because this gives us just about everything that we need to make this application work. So we have Hashcat, we specify our options, our hash file, our word list that we're going to be using to crack passwords, and so on. So this is definitely a lot more specific in what it does. So how do we use this funky cat and not be no jive turkeys? We got to understand one thing first. Hashing is a computed algorithm using a lot of math that I suck at. It is not this pretty looking Moroccan hash, but more like this here. So we'll have a password. We'll have a phrase like password 123, right? And when it's hashed, it's a computer either like MD5 or SHA-512, 256 or whichever. It basically takes the phrase, puts it through its algorithm, and it dumps out the output. And here is the overall format of a hashed password. We have the algorithm that we used, the options for it, the salt, and the actual hashed password itself. Now, I have made a generic word list called target hashes. And here is the syntax that we use it for. We specify our attack mode, which is number of 0 through 3, our hash type, which would be what type of hash that it is, outputting the file name, specifying our hash file, as well as our word list. So let's take a look at this. Now, the passwords from this target hashes, these are all MD5. Okay. Now, if we go back up our list here, we see what our hash mode is, 0, which is MD5. Now, -A, attack mode, as we see here, attack mode, references below, this is a digit, meaning number 3. So if we scroll down over to our attack mode, let's see if we can find it. There we go, attack mode, right there. Straight, combination, brute force, hybrid. We're just doing straight, so this is going to be 0. Okay. So we're just going to say hashcat-a 0-m0 because it's MD5. Then our output. Specify our target hashes and our passwords. So it's going to take the passwords and then recognize that this is MD5, and then compare it with our password list and see what available password that it has located, which are stank-a-leg or hello. So here's the basic password list that I put together. This one, first one, last one. As we see, we specified the target hashes, and this was the password that we used to break them. So this was, we're going to need, so in order for this to be more specific, we have to actually use singular username. But you see how this thing works. Other than that, we would have gotten an error. Now, our next tool that we're going to be going is John. Oh, damn, not that one. Not that. But John the Ripper. Password cracker, not the serial killer. Because his name is Jack. And there are actually a lot of American serial killers whose name is John, so that really doesn't help either. I think I'm kind of freaking myself out. All right, let us keep it moving. The syntax for John that we're going to be using is, this is an example of utilizing John. So we have John, we specify our word list, and we have a dump of hashes. Why did you go back one? And we have the format that those hashes are in. Now, here's the tricky part that I have not fully understood yet, which is when we use this application and it runs and it finds our password here, if we ran it again, it would error out because it already did this. It already did the password cracking. So it's like, I'm not doing it again. It just becomes this jaded substitute teacher. You know, it's like, all right, here's the work. Don't ask me no questions about it again, right? But then you raise your hand, and John just goes, "Put your hand down, stupid. I'm not talking to you no more." So everyone can have a good example. We just saw the screenshot of the output of John. Here is what happens if we try to use it again. John, not jogging. Specify our word list. Whoops. Equal sign. SHA-512. Oh, yep, I did have it correctly. And we have our hash dump. And as you can see, no passwords left to crack. See frequently asked questions. Why not just put that important question in this output? This is why I don't like you. So let's keep it moving. Next tool we'll be going over is Hydra. Obviously not for these, but from this logo right here. Now, Hydra allows us to crack logins themselves with both user and password wordless. So this works in a combination of these ways here. We can specify one user and a list of passwords. We can supply a list of users with a single password, or we can scan with a list of users and a list of passwords. So how do we use it? Let's figure it out. These are the switches that we would use. We have Hydra. We specify our switches for the users, specify switches for the password, the service, and specify the host. So the switches are lowercase l for a single user, uppercase for our list. Same thing with for passwords. Lowercase p for single password, uppercase p for a password list. Example. Let's see it. All right. Let's go over to here. Okay. Now for Hydra, actually we need to find for this one we're going to be using try hack me room information from here. So we have our basic task files here. Let's see. So let's take these into our first crack hashes folder here. All right. So let's determine what hash this is. Okay. Do a nice little Google search. Okay, so this is MD5 or MD4 type of a hash. All right, so we have our, let's look at our syntax for Hydra. Oh, whoops, these are logins. Sorry. All right, I gotta find a different tool for this first. Gotta find another machine that is on my current network to use as an example. Actually, I don't think I do. Now that I think about it. Sorry, I have another virtual machine up. Let's see what we have. Okay, we have 130. Let's look at SSH on here. Okay, so we have our Hydra. So what we're gonna do, we're gonna tackle SSH. So when it comes to SSH, here's basically what it's gonna be like, but not really. So let's go with Hydra. Obviously, we don't have a list of targets. That's basically what I mean. My bad. So we got Hydra. We're gonna specify our L. Maybe it's admin. P. Specify our full word list here. And since this is SSH, we don't really have to change it. So we're going to simply go our host address, which, if I remember correctly, is 130. Just take that. SSH on the end of it. And now what this is doing is taking the username admin, combining it with our password list from the rocky.txt. We have our host here. We have the service that we're attacking, which is SSH, and as we see here, it's running through the password cracking here. Now, if this is something that is running off of a different port, so like if it's, so for example, we have our HTTP right here, but also we have this here, port 8080. We can't specify the different port with the P option because uppercase and lowercase p are assigned to password lists. But there is another switch that allows us to specify a secondary port, and that's going to be -s, lowercase. This one right here. As we see, it's service on a different default port defined here. So that's how that works. And what this will do, it'll go through all the combinations until it finds one, and it'll show it in like towards like the bottom of the scan there. So now obviously we're not going to wait for that. We're going to keep it moving. All right. So our next thing that we're going to be going over is, oh damn. Woo! Scared me. Yeah, staring at that nappy-headed heifer just left me frozen in half stone. Let's get back to normalcy here. Medusa. This is our next application that we'll be going over. So, what is Medusa? Except being an ugly heifer with snake in the hair. Medusa is similar to Hydra, but for here, we specify the service that we're attacking with the M flag. So it's not SSH, it would be M for the module that we're attacking, and we'll specify it that way. So we have our Medusa specifying our host, our username, our password list, and what service that we are going after. Now, with that being said, demo time again. Let us see if we will not have any problems this time. Let's clear our screen. Obviously not in capital letters. Let's see. This is essentially how Medusa will work. So, same thing that was in our previous slide. Specify Medusa. And our host, which is going to be .130. Username. Password list. And what module we want to attack, which is SSH. And here we have no errors, so we'll be running through, same thing like it did with Hydra. As we see, it's going, but this is a little bit, but this will actually show us what it's doing, which is same thing as what Hydra would do. It would check SSH, the host, username, admin, go down the password list until it finds one, and then it'll present the results after. And stop once a password has successfully been found. So, after that, I have one other thing to say. Deuces! Just kidding. That is the end of our presentation for password cracking. Definitely hope that you guys enjoyed it. I try to keep these things as simple and basic as possible. I'm going to get to the more complicated stuff way later and everything like that. But I definitely had a great time learning this stuff on the fly. It probably took me maybe about a couple hours for me to get a good understanding of these things to be able to present them. But definitely leave, definitely drop a like, share it, subscribe it. And don't forget to, when you subscribe, turn on that little notification bell to stay updated every time I get a video out. I will be building some more on this course. Again, I hope you enjoyed it. I am Shy Ronin, and I am out.